You know the moment. Materials coming in fast, but something in the process isn't keeping up. Throughput drops, fuel burn climbs, and now your operation is, well, reacting instead of producing.
And it's usually not one big failure. It's small bottlenecks. Feed inconsistency, poor material flow, unnecessary recirculation. That's what quietly costs you tons per hour.
So today we're breaking down a machine designed to eliminate those bottlenecks. Not just crush rock, but control flow and protect uptime.
If you're responsible for hitting production targets and keeping your operation moving without interruption, stay with us.
Welcome to the Lippmann Academy Crushcast, built for decision makers in high-volume, aggregate, mining, and recycling operations. Nick and Jessica share practical insight for those selecting crushing equipment, managing quarry and plant production, and driving uptime and efficiency across material processing fleets. If your work is about moving rock, maximizing tons per hour, and running safer, more profitable sites, this is your show. This podcast uses AI-generated voice and presentation technologies with human oversight at every stage. All content is developed, reviewed, and approved by Lippmann. The information in these episodes is intended for educational and informational purposes only and does not constitute professional or business advice. Let's get started.
Welcome to this episode of the Lippmann Academy Crushcast. I'm your AI co-host, Jessica, and I'll be asking the questions today. And joining me is our other AI co-host, Nick, who thankfully has all the answers.
Jess, yeah, I try to have the answers anyway. Glad to be here.
So today we have a special product spotlight. We are dedicating this entire session to the 1200 JT mobile jaw crusher. And our mission today is to, well, really strip this machine down to its core geometry, the hydraulic architecture, the design. We want to understand exactly how the engineering choices made by Lippmann dictate things like tonnage, your total cost of ownership, and ultimately profitability on these high-yield quarry and recycling sites.
Yeah, it's a fascinating machine to unpack, honestly. If you look at the 30,000-foot view of this thing, when you're looking at the landscape of high-capacity mobile crushers, your defining metrics are basically material flow and maximum uptime.
Right.
Yeah, so the 1200 JT was designed specifically to just completely eliminate those traditional bottlenecks that plague high-tonnage sites.
Yeah.
It's highly configurable, but more importantly, it's engineered with an understanding of, the downstream consequences of every single component.
Meaning what, exactly?
Well, a wider belt here or, a heavier drive guard there, it fundamentally alters the daily operational reality for the crew on the ground.
Okay, that's exactly where I want to start, actually, that operational reality of the material flow. So, Nick, where does the journey begin for the material, and how does a machine this size handle, bulk loading without immediately creating a bottleneck?
Sure. So the journey obviously begins at the hopper, and managing bulk loading is notoriously difficult because if your loader cycle times are outpacing your crusher's intake, you immediately get spillage. Or, even worse, you force the operator to, feather the load, which just completely kills your efficiency. So the hopper is your primary interface between the site's rolling fleet and the processing plant. The 1200 JT uses this massive 8.9 cubic yard capacity hopper.
8.9, wow.
Yeah, it's huge. And that sheer volume is critical because it ensures a machine maintains what we call a choke-fed state.
Okay, so it's kind of like a massive funnel that just needs to stay completely full to work, right?
Exactly. When you have a chamber packed tightly with rock, you get proper interparticle crushing. The rocks are actually, breaking each other down under the compressive force of the jaw.
Which is what you want, right? Because it optimizes the shape of your final product.
Yep, and it maximizes the energy efficiency of the diesel engine. If that hopper runs low, you lose that interparticle dynamic entirely.
The jaw is just kind of biting individual rocks at that point.
Right, and that just accelerates wear on your manganese die plates and wastes a ton of fuel.
Okay, but let me push back on that a little bit, Nick, because if you have a physical setup with a hopper that large, typically a massive intake means a massive setup time. You're dealing with these thick steel side plates that have to be erected before you can even run a single ton of material.
Oh, for sure. That has historically been a huge pain point in the industry.
Yeah.
Setting up standard hopper sides usually meant, putting a maintenance crew on catwalks or ladders with heavy sledgehammers.
Oh, gosh. That sounds awful.
Yeah, just swinging sledgehammers to drive these massive steel pins into place. It's a very high-friction process. And then, after a few months of intense vibration out in the field, those pins just gall and seize up completely.
So how does the 1200 JT solve that?
Well, Lippmann engineered a hydraulic hopper side system that utilizes a tool-free wedge lock design.
A hydraulic wedge lock. Okay, that makes complete sense from a physics standpoint, actually. Because instead of relying on a static pin taking shear stress, a tapered wedge driven by hydraulic pressure would actually tighten its friction fit when subjected to the low-frequency vibration of the crusher.
Exactly, you totally nailed it.
And the crew can actuate this whole thing from the ground.
From the ground, yeah. You remove the sledgehammers, you remove the elevated working heights, and you just completely eliminate the physical strain. The setup is fast, it's safe, and it's controlled entirely from ground level.
Okay, so let's consider the variables of the site itself for a second. An 8-foot standard hopper is great, but what if a site manager is running, exceptionally large feeding equipment? If you have these massive articulating wheel loaders equipped with oversized buckets, an 8-foot target area suddenly looks like a very narrow funnel.
Oh, absolutely.
Right? Like if the loader operator has to meticulously aim every single dump, your cycle times are going to plummet. So what happens then?
Well, the engineers definitely anticipated that exact mismatch. So the 1200 JT can be equipped with these optional wing extensions that flare out, and they use the same hydraulic wedge lock controls we just talked about.
Wait, really? How wide did they go?
Those extensions push the hopper width from 8 feet out to an incredible 12 feet 4 inches.
Over 12 feet wide. Okay, that changes the entire kinematic flow of the loading phase, doesn't it?
Night and day difference, Jess.
Yeah, I mean, you are giving the loader operator a massive forgiving target. They can just approach, dump, and reverse in a fluid motion without constantly worrying about material bridging over the sides.
Precisely. Now, once the material actually hits that hopper, obviously it has to be conveyed into the crushing zone.
Right, into the beast.
Right. And the 1200 JT handles this with a massive 45-inch by 106-inch pan feeder.
And I imagine a pan feeder is necessary because an 8.9 cubic yard drop of raw rock from a loader bucket is immensely destructive.
Oh, it's incredibly violent, which is why the pan feeder is equipped with replaceable abrasion-resistant steel liners. It basically absorbs that initial kinetic shock, so the structural integrity of the feeder frame itself remains totally uncompromised.
Okay, so we have the material moving, but here's the next critical engineering hurdle, right? Once it's in, it needs to be sorted and crushed. You absolutely do not want to crush what is already small enough to pass.
Definitely not.
Because sending dirt, sand, and undersized rock through the main jaw chamber is just a massive waste of compressive force. It packs the flutes of the jaw dies, it increases the friction, and it rapidly accelerates wear. So what happens to all those fines before they hit the chamber, so the machine isn't working harder than it needs to?
That is exactly why the pre-screening stage is arguably just as vital as the crushing stage itself. So the 1200 JT uses a step deck grizzly section. It's available as a 66-inch grizzly for the long pan feeder option, or an 86-inch grizzly for the pre-screen option. But the defining feature here, Jess, isn't just the size of the grizzly bars. It's the drive mechanism. The pre-screen unit has its own independent power unit, completely separate from the pan feeder drive.
Wait. Let's stop and analyze that for the listener. Because the industry standard on a lot of machines is to just run the feeder and the pre-screen off a single drive system, right? To save on manufacturing costs and reduce hydraulic complexity.
Yep, that's the standard.
So by splitting them into independent drives on the 1200 JT, what specific mechanical advantage are you actually gaining out in the field?
You are gaining the ability to completely decouple your feed rate from your screening aggression.
Oh, interesting.
Yeah. So you hit a pocket of highly contaminated material out there, like heavy wet clay mixed in with the rock. You want to slow down your pan feeder so you don't choke out the jaw chamber.
Right.
But if your pre-screen is tied to the exact same drive, slowing the feeder also slows down the vibration of the grizzly bars.
Ah. And if you drop the amplitude and frequency of the grizzly, that wet clay just rides right over the bars and drops straight into the crusher, creating a massive clog.
Exactly. It's a nightmare. But by having a separate fixed-speed drive for the pre-screen, you can dial back the pan feeder to allow for more time to break up the material.
Wow, okay.
Yeah, you force the stratification of the material, you shake loose all the fines and drop them right through the grizzly bars before they ever reach the jaw. It protects the chamber and ensures the engine's horsepower is dedicated exclusively to breaking oversized rock.
That decoupling of the drives is honestly a brilliant solution to material variability. So, okay, once those fines are bypassed, the heavy rock finally reaches the heart of the machine, the muscle. Let's talk about the geometry of the jaw chamber on the 1200 JT.
Oh, the jaw chamber is the best part. This is the heart of the machine. It boasts a 34-inch by 48-inch gape in width.
34 by 48?
Yeah, and that 34-inch gape, just to be clear, is the distance from the stationary jaw to the moving jaw at the very top of the opening.
Right.
And because of that optimized with the gape geometry, the really precise nip angle of the dies, this crusher can handle a maximum feed size of 27.5 inches.
Which is huge. I mean, a 27.5-inch rock is a serious boulder.
It really is.
And for anyone managing a quarry, the ability to process a feed size that large isn't just a convenient little spec, right?
Yeah.
It fundamentally alters the economics of your site prep. I mean, if your jaw has a narrower gape, that 27-inch rock becomes a bridging hazard. It gets wedged at the top of the chamber.
Yeah, and then you have a major problem.
Right. To deal with it, you either have to constantly run a hydraulic hammer on an excavator to break the feed down before it enters the hopper, or you have to completely halt the plant, lock it out, and clear the jam.
Or you are forced to tighten your drilling and blasting grid in the quarry phase, which requires way more explosives, a lot more drilling hours, and significantly higher permitting costs. So being able to safely swallow and crush a 27.5-inch feed size essentially eliminates a massive portion of that secondary handling.
Yeah.
It pushes the bottleneck further up the supply chain and streamlines the entire extraction process.
That is the massive real-world benefit. That's the real return on investment. It's not just about crushing faster. It's about reducing the auxiliary heavy equipment required on site.
Absolutely.
Okay, so crushing the rocks is really only half the battle. Once that rock is fractured and passes through the closed side setting at the bottom of the jaw, we have to get it out of the machine safely and efficiently. A high-tonnage crusher is basically useless if you can't clear the discharge zone effectively. If the material backs up into the chamber, you just rip the main belt.
Right, it'll shred it.
Yeah.
So the discharge system on this unit is built to handle that immense volume without missing a beat. The main discharge conveyor is a full 55 inches wide.
55 inches.
Yeah. But the crucial metric for the site manager is actually the discharge height. The 1200 JT achieves a massive 15-foot 6-inch discharge height.
Okay, let's do the geometry on that, because when you drop material from nearly 16 feet, the angle of repose allows you to build a conical stockpile of up to 340 tons directly under the belt before the material peaks and forces you to actually move the crusher.
It's insane. That stockpile volume is a total game changer. It means your wheel loaders aren't just tethered to the crusher, constantly having to scoop away material every few minutes just to keep the belt clear.
They can actually focus on loading road trucks or managing the face of the quarry.
Exactly. Furthermore, that height allows you to feed directly into the hoppers of massive track-mounted secondary cone crushers, or screeners, without having to bridge the gap with a separate conveyor.
Which keeps the site's footprint super tight. Space is a premium on any site, and every extra conveyor you have to wire up and maintain is a liability. But Nick, moving 340 tons of processed rock involves immense kinetic energy, high-tension belts, and high-pressure hydraulics. How does Lippmann protect the crew operating it? Run through the safety features for me.
Safety architecture is built really deeply into the design here. First, there are 4 integrated emergency stops, strategically distributed around the chassis. Second, they utilized external grease points all over.
Oh, that's nice. So the maintenance crew doesn't have to contort themselves into the chassis, reaching over live tensioners and drive belts just to lubricate the bearings.
Right. Routine maintenance happens from a safe external stance. Additionally, the extensive use of hydraulic drives, rather than your traditional mechanical pulleys and V-belts, drastically reduces the number of high-speed rotating pinch points on the entire machine.
Makes sense.
But Jess, I'd say the most significant safety feature for the maintenance crew revolves around the jaw dies. The 1200 JT comes standard with specialized jaw die lifting tools.
Okay, I want to highlight why that is so important. Because jaw dies are these massive plates of austenitic manganese steel. And manganese is really unique because it work hardens, right?
Oh, yeah.
The more it gets pounded by rock, the harder and more brittle its surface becomes. So when it's time to replace those worn dies, the old school method required a welder to literally climb down into the jaws and weld a massive steel lifting lug directly onto that work-hardened plate so a crane could hook it.
And welding on work-hardened manganese is incredibly dangerous. The welds are super prone to cracking. Having a multi-ton plate suspended in the air by a brittle weld is just a massive hazard.
Right.
So the included lifting tools are mechanically designed to securely grip the geometry of the dies. It allows the crew to safely hook, lift, and swap the wear parts out without ever striking an arc or swinging a sledgehammer inside the chamber.
Okay, wait. Let me stop you right there, Nick. Because all these specs, the 15-foot discharge, the lifting tools, they sound absolutely incredible in a vacuum. But I really want to know how the 1200 JT actually stacks up against the competing rock crusher equipment manufacturers out there.
Oh, it's not even close. Honestly, when you look at what Lippmann includes as standard equipment versus the plastic parts and the endless upcharges from other machines, it's a completely different weight class.
Okay, well, we definitely need to dig into that. But first, let's take a really quick break. But we'll be right back with more of the Lippmann Academy Crushcast.
Stay with us.
When it's time to change jaw dies, compromise isn't an option. MPP aftermarket jaw dies are built to match your 1200 JT. The right manganese, the right profile, the right fit. Engineered by Lippmann, by the same team behind your machine. That means even wear, consistent throughput, and a faster return to production. Warranty-backed and in stock through your local Lippmann dealer. Ready when you are. Because when it comes to crushing, fit is everything. Lippmann, legendary crushing systems. Built right, backed by MPP Global.
Welcome back to the Lippmann Academy Crushcast. Now, let's rejoin Nick and Jessica as they continue the conversation.
Welcome back to the Lippmann Academy Crushcast. All right, Nick, before the break, you promised to spill the details on the Lippmann Edge over the other rock crushers.
I did.
So let's get into it. What are we actually talking about here?
Yeah, so let's break down the competitive advantages. And I'm not going to name any specific competitors here. We'll just refer to them as other machines or competing equipment. But the dividing line usually comes down to what is considered standard versus what is treated as an optional upcharge.
Give me an example.
Okay, for example, that massive extended main conveyor that gives you the 15-foot plus discharge height and the 340-ton stockpile capacity. On the 1200 JT, that is standard equipment.
Standard.
Standard. When you look at other machines on the market, achieving that kind of stockpile clearance requires purchasing an optional extended conveyor package. It's an immediate hidden cost.
It's the illusion of a lower base price, isn't it?
Yeah.
You buy the cheaper machine only to realize you now have to go out and rent a wheeled stacker to handle the output, which completely negates your initial savings.
Exactly. It's frustrating for buyers.
What about structural durability? You mentioned component quality before the break.
This is where you see severe divergence in design philosophy. Like we said, a jaw crusher basically creates a localized earthquake. The low-frequency acoustic energy and the constant vibration cause severe kinetic fatigue over time.
Right.
The 1200 JT utilizes heavy-duty steel crusher drive guard doors to protect the vital hydraulic and mechanical components. Competing equipment often just settles for plastic guard doors to save weight and manufacturing costs.
Plastic. You're kidding. In a high-impact, high-vibration quarry environment exposed to intense UV radiation, it's not just the risk of a stray rock shattering a plastic panel, it's the fact that polymers literally degrade and warp under that kind of environmental stress over time.
Exactly.
Steel drive guards aren't just covers, they are structural armor.
You're totally right. And when you look closely at the size advantages and the dimensional tolerances, the differences become really stark. We discussed the 34-inch jaw gape. The standard on many competing machines is only 32 inches.
Okay, and 2 inches might sound negligible on a spec sheet, but in fluid dynamics and bulk material flow, a 2-inch reduction at the choke point creates an exponential increase in bridging probability.
Right. It's literally the difference between a slab sliding perfectly into the nip angle and a slab just wedging sideways.
Yep, it creates a severe bottleneck. And the dimensions are restricted everywhere else, too. The 1200 JT runs a 55-inch main conveyor. Competitors are often down at 48 inches.
Wow.
The standard discharge height is over 15 feet 6 inches. Competitors often max out around 13 feet 1 inch. Even the dirt conveyor, the side belt removing the fines from the pre-screen, that's 32 inches wide on this machine compared to just 26 inches on competing models.
And a narrower dirt belt just means less capacity for bypass. If you hit a seam of heavy fines, a 26-inch belt will easily overwhelm and spill, burying the tracks of the machine in dirt.
That's a mess to clean up. And wider belts across the board means slower belt speeds are required to move the exact same tonnage, which dramatically reduces wear on the belt splicing and the idlers. I want to point out to the listener that these differences aren't just minor spec bumps. They represent massive differences in daily tonnage, ease of use, and overall durability in a really harsh quarry environment.
It's all interconnected. And finally, there is the issue of crew accessibility and optimization. The 1200 JT includes a robust jaw maintenance platform as standard, providing a highly secure, elevated staging area for the crew.
That's huge for safety.
It is. It also integrates automatic feeder controls. These systems actively monitor the load on the jaw and automatically adjust the pan feeder speed to maintain that perfect choke-fed state we discussed earlier.
Which is brilliant.
But on several competing machines, both the maintenance platform and the automatic feed control loop are completely absent.
Completely missing. Which forces the operator to manually feather the feed rate based on what? Visual guesswork?
Pretty much.
Wow. Okay, so Nick, what is driving all of this heavy machinery? To drive a machine with this level of automated feedback and raw capacity, the power plant has to be incredibly robust. How is the engine and control interface architected, and how does the operator keep an eye on it all?
The power plants are top tier. You have the option of either a Cat C13 or a Volvo D13 diesel engine. Both of them provide over 500 horsepower, but more importantly, they offer the deep torque curves required to recover instantly when a massive boulder drops into the chamber.
Right, you need that torque.
Exactly. But all that power is useless without precise control. So the machine features a 12-inch ultra-bright display screen mounted in the control panel.
The luminance of the screen is critical, actually, because you're dealing with high glare environments, blinding dust, and direct sunlight. If the operator can't read the telemetry, they're basically flying blind.
Oh, for sure. So the interface gives them total command. From that single home screen, they can easily monitor vital stats like engine load, coolant temperatures, and hydraulic oil temperatures. But crucially, Jess, they can monitor the CSS, the closed side setting. Necessary adjustments identified on screen are completed via mechanical levers, hydraulically. And for fleet management, the system offers an optional telematics package. This provides complete off-site visibility. A site manager sitting in an office miles away can pull up a dashboard and monitor real-time production rates, fuel consumption, and predictive maintenance alerts.
Which totally shifts the maintenance paradigm from reactive to proactive.
So just to give a final wrap-up, the 1200 JT represents a truly holistic approach to crushing. It delivers a longer feeder, a larger jaw chamber, enhanced safety, and taller discharge heights, all in one highly configurable package. By combining a massive hopper with an independent pre-screen and standard 16-foot discharge heights, it actively neutralizes the most common causes of site downtime.
It's just phenomenal engineering.
It's engineered to process larger feed sizes, stratify material more efficiently, and stockpile greater volumes. It's a configuration built for absolute maximum tonnage.
Well said, Nick. So for those of you managing operations and looking to recalculate your site's throughput, you absolutely need to explore the exact specifications for yourself. Contact a dealer from the network by visiting the website at lippmanncrushers.com.
Highly recommend it.
And to our listener, be sure to download, subscribe to never miss an episode, and share the Lippmann Academy Crushcast podcast with your colleagues.
Thank you for joining us as we unpack the engineering behind the iron.
Catch you next time.
Thanks for joining us on the Lippmann Academy Crushcast with Nick and Jessica. To explore more insights, catch new episodes, or learn how Lippmann is helping customers run smarter, safer, and more productive operations, visit lippmanncrushers.com and follow Lippmann Academy online. We appreciate you listening. See you next time.